Hello and welcome back, Math130 students. So this is page 25, section 4.8. So we are going to be closing out chapter 4, which is nice. So we're going to wrap it up nicely. So 4.8, solving polynomial equations by factoring. So it says, use the zero product property to solve a factored polynomial equation. So we have the zero product principle, or the zero product property. It depends on what book you read. Sometimes they call it a principle. So you say it's the zero product principle, and sometimes they say it's the zero product property. So it just kind of depends on what book you read. So I like to refer to it as the ZPP, right? You know that you need to use a zero product property or principle. So what this is really saying is that if we have some numbers that are being multiplied together and we know for a fact that it's going to equal to 0 after you multiply, well, it must mean that one of those numbers that you originally multiplied must have been a 0 in order for our result to be 0. So when we have a polynomial, we can split that up. We can say that our x is equal to 0 because that's one polynomial that we have, and we also have our x plus 2. So our x plus 2 also gets equal to 0. So you kind of split it up and set each set of parentheses to 0. So for example, we have number 1, 4w times 10w minus 7 is equal to 0. So we're going to set each thing here equal to 0. So we have our 4w. So let's say 4w is equal to 0. So to get w by itself, let's divide by 4. So we're going to get that w is equal to 0. So that was 1. Now, for our second part, we're going to have to set this parentheses equal to 0 as well, since these two were being multiplied together. So what we're using is the zero product property or principle. So now we have that 10w minus 7 is equal to 0. So I'm going to add 7 to both sides. Now you'll get that 10w is equal to a positive 7. To get the w by itself, since it's attached by multiplication, is the opposite, which is going to be division. So you divide by 10, and you're going to get that w is equal to 7 over 10. So you have w is equal to 0, and w is equal to 7/10 as your two answers. For number 2, it's the same process. So we know that we're going to split this, because these two are being multiplied together. And we can use the zero product principle. So we're going to split each of these up and set them both equal to 0. So we are going to have a plus 2 is equal to 0. So I'm going to get the a by itself, so I'm going to subtract 2 to both sides. So that a is equal to a negative 2. So that is going to be my final answer. Now, we're going to have a minus 5 is equal to 0. So I'm going to add 5 to both sides. So I can get that a is equal to a positive 5. So that is how I'm solving each one of these. For number 3, I do believe there's a typo. Like I said, I am not perfect. Sometimes that happens. I write all of these notes by hand, so it takes me quite some time to put it all together for you guys. But I am going to say my typo was I needed to put this equal to 0. So I forgot the equal to 0. Otherwise, you're not solving, right? So the reason I know I made that mistake is because it specifically said in my directions to solve. Well, in order to solve, you need that equal sign, okay? So that's where I know my typo happened. So from here, what do we know? Well, we know that we have 8w plus 5 squared is equal to 0, okay? Well, that square, because we know that that is going to be an exponent, it's really just repeated multiplication. So we're going to write this, it's saying that it's being multiplied twice. So we have 8y plus 5, and because of the exponent, we know it's being multiplied again, so 8y plus 5 is equal to 0, right? It's written twice, so there it is, written twice, and it's being multiplied. So that means we can split using the zero product principle and solve each set of parentheses equal to 0. So over here, I'm going to have my 8y plus 5 is equal to 0. So subtract 5 from both sides. So that 8y is equal to a negative 5. From here, I can divide by 8 on both sides, so that y is equal to a negative 5 over 8. Now, for my second set of parentheses, it's the same thing. Now, you can just say that it's repeated, or if you really need to get into that habit of writing it twice, it doesn't hurt. So you can either realize that these two are exactly the same, so you already know that this is going to be your answer that you get. But let's say you didn't realize that and kept going, that's fine. You would still get 8y plus 5 is equal to 0. So to solve for y, you subtracted 5 on both sides to get that 8y is equal to a negative 5. And you still have to divide by 8 for the same reasons, and you still get that negative 5/8, which was exactly the same like I was saying before. And I already knew that was going to happen because it was exactly the same, right? It's 8y plus 5 squared. Okay, so now for number 4, because I have it equal to 0, I can use my zero product principle. So I'm going to split it in half since it's being multiplied and it's equal to 0. So the first half, I'm going to have my 4q plus 5 is equal to 0. So to solve for q, I'm going to subtract 5 to both sides. So that 4q is equal to a negative 5. From here, divide by 4, since you're being multiplied by q, and q by itself is going to be a negative 5 over 4. And so we take our second set of parentheses, which is that q minus 5, and set that equal to 0. So I'm going to add 5 to both sides, so that q is equal to a positive 5. Okay. Alright, so now it says solve polynomial equations by factoring. So here you can use a variety of skills and patterns that we've used. So some of the things that we've used is, you know, when the leading coefficient is 1. So I guess for methods, for factoring, we have a few, right? So I'm just going to write it over here on my scratch paper. So we know that we have the AC method. That means you did the A times the C, your B, and you rewrote your B value. And remember, we're talking about AX squared plus BX plus C equal to 0. So it all comes from, oops, that 0 does not look like a 0. There we go. AX squared plus BX plus C is equal to 0. So we know that we are going to be rewriting that middle term, that BX term. Now for our second method, we can do the guess and check. And I know some people do kind of like this box method, and to tell you the truth, I'm not very familiar with it and I don't want to confuse anybody, but if you happen to do the box method, that is wonderful. It's fantastic. And actually, if you have a video to submit, I will give you credit if you do a student to student activity showing me how you can use the box method for factoring. That would be cool to see other students introducing a new method if you guys are up for the challenge, if you guys are actually listening to my videos. Let's go ahead and try this out. Oh, I forgot, there's also the greatest common factor. And this is actually what you should always be trying first whenever you factor. So this is actually a really important one. And we also have our special ones, which means we have our difference of squares. And then we have our difference and sum of cubes. So remember, that looks like if we were to have a squared minus b squared, that's going to equal to a plus b, a minus b. And for the cubes, degree 3, we have 2. We have x cubed plus y cubed, and we have the x cubed minus the y cubed, right? And those formulas are in section 4.7 in more detail if you guys need review. Okay, so let's go ahead and look at number 1, now that we briefly reviewed that. So I'm going to go ahead and do my guess and check. I just decided I like that method, so I'm going to try to skip around. So let's do our guess and check method. If you guys like the AC method, stay with the AC method, that's fine. But the method that I want to choose for number 1 is going to be guess and check. So I'm going to look at the coefficient of the first term. So notice how this coefficient, even though you don't see it, it's really a 1. So I know that the first term is 1, and you can only get that by 1 times 1. So the first term is the first inside the parentheses. So the only combination that can be is 1 times 1. Now I am going to look at the coefficient of the last term. So my last term is a 20. And I'll worry about the signs later. So I know that's 1 times 20, 2 times 10, and 4 times 5. So my last is going to go here. And what I want to happen is that I really want my middle term to add up to when I either add or subtract the last term together. So I'm obviously constantly thinking, does this add up to -1 when adding or subtracting? So let's see if this actually happens. Well, with 1 and 20, there's no way I'm going to get a -1, so I know that combination won't work. 2 and 10, well, 10 minus 2 is 8, so there's no way that's going to add up to a -1. What about 4 and 5? Oh, well, if we have 4 and 5, and eventually want it to equal to -1, then I would need a -5 and a +4 in order for that to happen. So -5 plus 4 would give me a -1. So those are going to represent my last terms. So I'm going to have a +4 and a -5. So, and all of this is equal to 0. And don't forget, with our first term, we do have that x squared. So make sure that you guys have the x in those terms as well, those first terms. So now what you really have is x plus 4 times x minus 5 is equal to 0. So according to the zero product principle, I'm going to split it in half. And this first term is going to be x plus 4 is equal to 0. So x is equal to -4 is going to be one answer. Now for my next term, I have my x minus my 5 is equal to 0. So I'm going to have that x is equal to a +5. So I have my two answers. My two answers here are going to be -4 and a +5. Okay. And remember that over to this side I had written some notes of the different methods how to factor. Sometimes it's nice to just have a little brain dump, right? And it's just there for your reference as well. Okay, so let's look at number 2. Let's look at our different methods that we have. We have 3x squared minus 18x squared plus 24x is equal to 0. Remember, I starred this one. So the first thing you want to do is really think about the greatest common factor if it exists, okay? So whenever I think about the different methods, always go to the greatest common factor first. So, do we have a GCF? Well, let's look at the coefficients. I have 3, 18, and 24. Yes, so I have a greatest common factor all of those numbers, 3, 18, and 24, all have a 3 in common, so it's part of my GCF. The next thing I want to look at is going to be the variables. So does each term have a variable in common? It does. A 3x is in common in all of them. So I'm going to deal with my GCF first. So I have a 3x. So I'm going to factor a 3x from each term. So from our first term, 3x squared divided by 3x gives us just x. Now let's look at our second term. So we have a negative 18 divided by 3, so that's going to give me a negative 6. X squared divided by x will just give me an x. Now let's look at our last term. So 24 divided by 3 is going to give me a 8, so positive 8, and x divided by x is going to be 0. So that is what we're going to get. So then from here, we know that we have our GCF, which was that 3x. Now, can we factor that inside any further? Can we factor out this x minus 6x plus 8? Well, we can go ahead and do the AC method, if that's something that students like, where we actually split it up into 4 terms. And what's really nice about this is that the leading coefficient is 1, so we know that it's going to be whatever these two are equal to. So if I were to factor this out, or actually identify my a value as 1, b as negative 6, and c is equal to 8, then my a times my c is a positive 8, my b value is a negative 6. So if I'm looking to two numbers that multiply to 8, these are the different combinations, but I wanted to add up to a negative 6. And then the only way I can do that combination is if I have a negative 4 plus a negative 2. That gives me a negative 6. So I'm going to have a negative 4 and a negative 2. So now I know exactly what's going to be inside my parentheses, because that leading coefficient was 1. So I'm going to have that this is equal to x minus 4 and x minus 2 is equal to 0. So now when I set each thing equal to 0, because I split it in half, I will have x minus 4 is equal to 0, so that x is equal to a positive 4. X minus 2 is equal to 0, so x is equal to a positive 2. So those are going to be my two answers. So my two answers are that x is equal to 4 and x is equal to 2. So that's why I boxed it, because these are your final answers. Okay. Well, if you guys have any questions, always feel free to email me. So let's look at number 3 and number 4 a little bit more closely. So if I'm looking at number 3, the first thing that I realize is that I want to use the zero product principle. But think about it. What's our first variable? That first variable is z, which stands for 0. So you really want this to equal to 0. So the only way to do that is to add 8 to both sides. So then I'll get my 12a squared plus 28a plus 8 is equal to 0. Okay? So then from there, you might think, okay, well, I know all of my different methods of factoring. I have them memorized now, hopefully. And the first thing you always want to look for is a GCF. So do you have a greatest common factor? Well, if you look at the coefficients, they are all even numbers, so 2 definitely goes into all of them. And let me see, does 28 divide by 4? It does. So actually even a bigger number that goes into all of them would be 4. So you're always looking for the GCF, so it's the greatest little number. So that biggest little number is going to be a 4. So I'm going to factor a 4 out from this entire trinomial. So I would have 12 divided by 4, which is a 3a squared, plus 28 divided by 4 is a 7a, and 8 divided by 4 is a 2. So then from here, we can either do a guess and check, or we can do the AC method. Well, let's just alternate. Let's just do this. Well, let's just do the AC method. Let's make sure everybody understands the AC method. And remember, our leading coefficient, our A, is not equal to 0. So you have to be really careful because you're thinking about this as the leading coefficient, okay? So you want to be careful also because you're actually using the variable A. So just be aware of that. So let's just pretend for now that this is a 3x squared plus 7x plus 2 is equal to 0. So I really want to make sure you guys understand why I'm changing it to an x. I just want to be careful using this because in our original equation, that 3a squared plus 7a plus 2, so our variable is an a, but remember our general equation that we're using to get our a, b, and c value is ax squared plus bx plus c. So that can be confusing of, wait, which a do you mean? So I just really want to be careful to represent that here we're talking about our 3 being our a. So that's why I'm switching it to x, just so we don't get variable happy. So I know that my a variable is equal to 3, my b is equal to 7, and my c is equal to 2. So now when I do the a times c and the b value, well, a times c, 3 times 2 is 6, and my b value is 7. So the only two numbers that multiply to 6 and adds up to 7 would be a positive 1 and a positive 6. So positive 1, positive 6. But be careful, our leading coefficient is not 1. So that means I am forced to rewrite this middle term. So now I have a 3x squared, and if I rewrite that middle term, it'll be a positive 1x plus 6x plus 2 is equal to 0. So then from here, you can simplify a bit. So 3x squared plus 7, oops, that's not what I want to do. Remember, I am factoring. So when you're factoring, you did all of this work to get it into a 4-term polynomial. So now you want to split it in half. Sometimes it's good just to pause and be like, okay, like, where did I start? Remember, your directions were to factor. And it's, you know, this is a long problem. So if you're like, wait, I sneezed and I lost my place, what are you doing? You are factoring, okay? And you just rewrote that middle term using the AC method. So now, factoring out those first two terms has an x in common, so I'm left with a 3x plus 1. My sign is a plus, so I drop it down. My GCF on that side would be a 2, so I'm left with a 3x plus 1 equal to 0. So now my common parentheses is 3x plus 1, and my leftovers are going to be my x plus 2 equal to 0. So now I split each one equal to 0. So 3x plus 1 is equal to 0. So 3x is equal to a negative 1. So x is equal to a negative 1/3. Now, dealing with our right-hand side, we have x plus 2 is equal to 0. So x is equal to a positive 2. So that is how I'm going to get my two answers here. So I got my two answers by making sure I got my GCF using the AC method. I rewrote it using 4 terms, and then I factored, and then I set each set of parentheses or each factor equal to 0 using the ZPP rule. So I got x is equal to negative 1/3 and x is equal to positive 2. Okay, well, I hope you guys are having fun. Let's look at number 4. So I'm just going to go ahead and give myself a little bit more room, clean this up a little bit to make it a little bit more presentable. Okay, so here we want to use our zero product principle. So remember, the first thing we need to realize is that we need a 0. So in order to do that, I am going to subtract 3x from both sides. That will give me that 0 that I need. So now I have an x squared minus a 3x. So I'm just going to write that a little bit nicer over here. X squared minus 3x equal to 0. So then from here, if I'm trying to factor, then I'm going to look at my greatest common factor. That would be an x. That's what they have in common. So I'm left with an x minus a 3 is equal to 0. So now that it's factored as possible, I set each factor equal to 0. So I have my x is equal to 0. And you also have your x minus your 3 is equal to 0. So the first one is already solved. Perfect. And then for your second one on the right hand side, you add 3. So the x is equal to a positive 3. So you get that x is equal to 0 and that x is equal to a positive 3. Okay, so Math130, Chapter 4, page 27. How do the roots, the solutions, the zeros, the x-intercepts, and factors of a polynomial function are related? So how they are related is that they all represent the exact same thing. So they're really just different ways of saying the exact same thing, okay? So the solutions, like we just found in the previous section, is the same thing as the zeros, which is the same thing as the x-intercepts. Remember, if I'm specifically talking about the x-intercepts, then we're looking at our graph that's written in that y is equal to mx plus b form, and we have some linear equation where the point where it's the x-intercept has a special ordered pair, which is going to be x and 0, where the y value is equal to 0 and it's some number for x. Which also tells us that it's going to be the 0 because you're looking at this 0 over here. And the roots and the solutions are just different ways of saying the zeros and the x-intercepts. So for example, it says for the function, solve and find the x-intercepts of the graph of the function. So they're asking you for several things here. So for this one, first of all, they're asking you for the x-intercepts. So you know that you have to write it as an ordered pair. So here we go. We have f of x is equal to 25x squared minus 49. Well, we already know that this f of x is just a fancy way of just saying our definition is just y. So this is y is equal to 25x squared minus 49. And because I'm thinking about the x-intercepts, what you have to do, remember, is that you let your y value equal to 0. We talked about that in previous chapters. So you're going to let your y value equal to 0. So you have your 25x squared minus 49. Now your goal is to solve for this equation. So the only way that you can solve it is by using the zero product principle. So you already have that 0, so that's perfect. Now that means you're just going to make sure that it's into its products or its factors. And the only way to do that is to factor. So we really have that 0 is equal to, and let's think about these for just a second. If we have 25 and 49, well, I already know that 5 squared is equal to 25. I also know that 7 squared is equal to a 49. These are what you called perfect squares. So because I know that these are perfect squares, and I have a subtraction, remember our subtraction can also be said as the difference when you're reading it in a word problem or understanding the vocabulary. So now you know, since you have perfect squares and the difference, it's the difference of perfect squares, which means x squared minus y squared is equal to x plus y, x minus my y. Okay, so now you know that this is going to be my 5x squared minus my 7 squared, so that you have 5x minus 7 and your 5x plus 7. So you set each one equal to 0, so that 5x minus 7 is equal to 0, so that 5x is equal to a positive 7, and x is equal to a 7/5. Right? Your goal is to add the 7, divide by 5. And in our next one, we have 5x plus 7 is equal to 0. So I subtract 7 from both sides, and then I divide by 5 to get my negative 7/5. Now, another way to phrase this, or use this type of function, is to find a value. So for example, number 2. For the function f of x, find x when f of x is equal to negative 4. So it says to find x, and this is the description that it gives us. So we are going to use this information. So we are going to use that f of x is equal to a negative 4. Well, remember that y is equal to f of x. So you're really just saying, let your y value equal to a negative 4. So you're just like, okay, well, if that's the case, I have f of x is equal to 8x squared minus 18x plus 5. So now we're changing this to y is equal to 8x squared minus 18x plus 5, because function f of x can be described as the y value or the output value. And that output value, what this is saying, is making sure that we let the y value equal to negative 4. So now I'm going to have a negative 4 is equal to an 8x squared minus 18x plus 5. So I want to use the zero product principle. So I need to get that 0 there. So in order to do that, I'm going to have to add 4 to both sides. So now I have 0 is equal to 8x squared minus 18x, and 4 plus 5 is going to be a positive 9. So now I have 0 is equal to 8x squared minus 18x plus 9. I rewrote it so I can have some more room. So then from here, I know I want to now factor, if possible. So if I'm going to factor here, I look for, remember, the GCF is always a good starting point. So I have 8, 18, and 9. There is no greatest common factor between the coefficients, and there isn't, oops, that was really an 8. I meant to just not do that. And we don't have a variable on common. So for this one, I'm just going to go ahead and do the guess and check method. And you know, the alternative would be the AC method. And it really just depends on what you prefer. So I'm going to prefer the guess and check. But if you do the AC method, you will get the same answer. So I'm going to have 0 is equal to parentheses. So I'm going to look at that first term. That's an 8. So that's 1 times 8 and 2 times 4. I'm also going to be looking at this last term, which is 9. So that's 1 times 9, and it's also a 3 times 3. So I know the last term goes there, and the first, so the first in the parentheses is the first term. And then the last in the parentheses is the last term. So I'm going to go ahead and just, guess and check. So I'm going to guess first. So I'm going to guess the 2 and the 4. So I'm going to get that this is going to be 4x and 2x. Now, because I guessed that, now I want to guess my last term. So I think because I want the 18, I'm going to go with 3 and 3. So this is going to be my first guess. Now I'm going to FOIL so that I can check if it worked. Because I'm not sure. All I did was guess, right? That's part of the guess and check method. So when I FOIL this out, I would get a 12x squared. Oops, not a 12x squared. I would get an 8x squared, a 12x, a 6x, and a 9. And you want that middle term to be negative, since it says it's negative. So if they're both negative, that could work. Because if I have a negative 12 and a negative 6, that gives me a negative 18. And our negative 3 times negative 3 gives you a positive 9. So this is perfect. So now, I'm going to rewrite this over here. I write kind of big, and that's okay. So I have 0 is equal to 4x minus 3 and 2x minus 3. I remember the previous line before that was 0 is equal to 8x squared minus 18x plus 9. And we did verify that this equation is equal to the top. Okay? So now, using the zero product principle, I'm going to set each parentheses equal to 0. So 4x minus 3 is equal to 0. So that 4x, when I add 3, it's positive 3. And when I divide by 4, I get a 3/4. For my second parentheses, that 2x minus 3 is equal to 0. I add 3 to both sides, and I divide by 2, so that x is equal to my 3/2. So those are going to be my answers, 3/4 and 3/2. Now in this section, we are also going to have some word problems, some applications. So let's look at the first example. A stained glass window is shaped like a right triangle. The hypotenuse is 15 feet. The length of one leg is more than the other. Find the length of the legs. So it's really nice that they already went ahead and gave us a diagram, because usually you have to draw that by itself. So that was perfect. So we know from before that if we have a right triangle, that really means there's a square. And I knew the square was going to be there because it specifically said that hypotenuse is 15 feet. So I know that my 15 is equal to my hypotenuse. And always directly across from the hypotenuse is that little square. So we have x, and I do believe there is a typo. It should be the length of one leg is, and it should have the number 3 in there, is 3 more than the other. So that's how they got that x plus 3. So it's 3 more than the other. So because of this, then we know, since it's a right triangle, that this is going to represent, oh, that was a terrible triangle. Let me try that again. There we go. Since that's a right triangle, then we can use the Pythagoras Theorem, which tells us that a squared plus b squared is equal to c squared. and our c squared is equal to 15, which is our hypotenuse. Okay. So what we really have is we have one of the leg squares plus the other leg squared is equal to your hypotenuse squared. And like I said, we already had the hypotenuse. The hypotenuse was already going to be a 15. So we already knew that was going to be our hypotenuse. Now what's going to go inside is, well, do you see this x? That's going to go in here. So I'm going to have x. Now we also have our other leg. That other leg is going to go in here, so that's going to be my x plus 3. So now you have x squared plus x plus 3 squared is equal to 15 squared. But 15 squared is just 15 times 15, which is 225. So then from here, what you want to do is you want to go ahead and FOIL this out. So you have your x squared plus, and this term is really telling you to write it twice, right? Since it's an exponent. So you have your x plus 3 times your x plus 3 is equal to your 225. So I'm going to go ahead and give myself some more room. I have my x squared plus x plus 3 times x plus 3 is equal to my 225. So now that I've rewritten it over to the side, I just always like to have more scratch paper than not enough. It's just easier to not make a mistake. So over here on my scratch paper, this is what I have. So what I want to do is I want to FOIL this middle term out. So I'm going to do my first, my outer, my inner, and my last. So don't forget you still have that x squared over here. And now when I FOIL that, I did my first, so that's x squared, my outer, so that's 3x, plus your inner, plus your last. And all of that was equal to your 225. So combining like terms, I have x squared and x squared, so that's 2x squared. You also have 3x and 3x, so 3 plus 3 is going to give you your 6x. And you still have your plus 9 is equal to 225. Well, from here, what you really want to do is use the zero product principle. So you need that 0. So in order to get that 0, you need to subtract 225. So you will get your 2x squared plus 6x, and you have a positive 9 minus 225, which is a negative 216, is now equal to your 0. Now to factor, you want to make sure that you get all of your coefficients, and all of your coefficients are even, so you're going to factor by a 2. So you're left with an x squared plus 3x, and negative 216 divided by 2 is going to give you a negative 108, is equal to 0. So then from here, you can either do the guess and check, or you can do the AC method. Well, since my leading coefficient is 1, I might as well go ahead and do the AC method. So if I do the AC method, I know that my A value is 1, B is equal to 3, and my C is equal to negative 108. So then my A times my C value is negative 108, and my B value is a positive 3. So I want two numbers that multiply to 108 and adds up to a positive 3. So let's start thinking about some factors here. Well, I know that there's definitely 1 and 108. I also have 4 times 27. And I have 2 times 54. And I have 3 times 36. And I have 6 times 18. And I also have my 9 times 12. So it definitely looks like the 9 and the 12 will add up to give you a 3. The way to add those up to give you a 3 would be a positive 12 and a negative 9 will give you a positive 3, which is what you want. So a positive 12 and a negative 9, and these are going to be your parentheses. So now I know that this is going to factor as x plus 12 and x minus 9. And I'm also going to bring down my GCF, which was a 2, all equal to 0. So then from here, I'm going to set each thing equal to 0. So each factor. So 2 is equal to 0, x plus 12 is equal to 0, and x minus 9 is equal to 0. So for this first one, where it's 2 is equal to 0, well, that can't happen. 2 can't be equal to 0, so that doesn't work. For this x plus 12, well, if I subtract 12 to both sides, I have that x is equal to a negative 12. For the last one, x minus 9, well, if you add 9 to both sides, you would get your x is equal to a positive 9. So that is going to be your answer. So we have our answer as x is equal to negative 12 and x is equal to a positive 9. So those are going to be the lengths of the glass-shaped window. So don't forget here that it specifically says in feet. So the lengths of the windows would be well, can it be negative? Can length ever be negative? No, you can't ever have like negative 12 feet. That doesn't make sense. So we throw that answer out. But we do have a possibility of having 9 feet. So we can say that we have one that is 9 feet. Remember, that was our x value. And now the other one, don't forget, was the x plus 3. That was the other leg. And we're saying that it's equal to 9. So if I subtract 3 from both sides, I'm going to get that x is equal to 6. So I have 9 feet and 6 feet. And remember that 6 feet represented that x plus 3. So that is going to be my final answer for number 1. So I needed to zoom out a little bit, right? Ask myself, what am I doing? Oh yeah, I'm finding the legs of the stained glass window that's shaped like a right triangle. So the fact that it was shaped like a right triangle, that's what made it be able to figure out what the lengths were going to be. So that 9 feet and that 6 feet. Okay. So if you guys have any questions on that, please feel free to email me. So obviously I did not, when I was writing these notes out, I didn't give myself enough room, but you guys have scratch paper hopefully nearby, and also you have this video to refer back to as notes. So let's zoom in on number 2, okay? I'm going to go ahead and give myself enough room, so I'm going to erase this. So just give me a second. Alright, so number 2, we have our word problem. It says the area of a bulletin board is 52 square feet. The length is 3 feet less than 4 times the width. Find the length and the width of the bulletin board. So let's think about this. So we know that we have a bulletin board and it's in square feet. So that means we were going to have a rectangle for a bulletin board, right? So we know so far that the area is equal to 52. So we know that the general equation for a rectangle, for an area, is going to be length times width, okay? So far we know what the area, what this is equal to. It's equal to my 52. Now, it specifically says the length is 3 feet less than 4 times the width. So we don't know what the width is. That's the I don't know. So here we're going to have W is equal to the width. So here is my W. That's going to be my width. Now we know that the length here, so length, is 3 feet less than 4 times the width. So 4 times the width would be 4 times W. And 3 feet less than, well, less than is to subtract. And that less than also tells you to reverse the order. So you're going to have 4W minus, and it says the length is 3 feet less, so I have 3, okay? So that is what my length is equal to. So I have my length is equal to 4W minus 3. And don't forget that W here represents my width. So now, since I have this equation of area is equal to length times width, well, we already know that the area was 52. The length, we are saying it is my 4W minus 3, and it's being multiplied by that W. So what we do, we are going to distribute that W inside, so that 52 is equal to a 4W squared minus a 3W. So in order to use the zero product principle, I need this to be a 0, so minus 52 to both sides. So that's how I get this 0, which is exactly what I want, and 4W squared minus 3W minus my 52. From here, we want to factor now. So in order to factor, we want to think about the GCF. Is there a greatest common factor? Well, if I have the coefficients 4, 3, and 52, let's see, does 52 get divided by 3? No, it doesn't. So it does not have any GCF. So now, let's just do factor. Let's do the guess and check. So for our, actually, no. Let's do AC method. Why not? This is, I think, a good opportunity for those people who really like the AC method. So AC method. When we are factoring. So we have that 0 is equal to my 4W squared minus 3W minus my 52. So then from here, if I'm looking at my A value, that's 4, B is negative 3, and C is a negative 52. So my A times my C, so 4 times a negative 52 is a negative 208. My B value is a negative 3. So I want two numbers that are going to multiply to negative 208 and add up to a negative 3. And that's how I'm going to rewrite that middle term. So I'm going to look at my different factors of 208 and pick the best pair. So I'm going to pause this and give you guys the solution. So now I found the factors. I found them doing negative 16 and positive 13, doing the factor tree. So I have negative 16 and 13. I just don't want to make this video too long. So here, when I rewrite this, I'm going to have my 0 is equal to my 4W squared. And since I'm rewriting the middle terms, a negative 16W plus a 13W minus 52 is equal to 0. So now I split it in half. So I have a 4w, w minus 4, plus and 52 divided by 13 is a 4. So that means 13 would be the GCF, and I have a w minus a 4 equal to 0. So now I have w minus 4 is equal to 0, and my leftovers, 4w plus 13 is equal to 0, since I'm splitting it in half. So now I have that w minus 4 is equal to 0, so w is equal to 4. I also have that 4w plus 13 is equal to 0, so that 4w is equal to a negative 13, and w is equal to a negative 13 fourths. So remember, our w was equal to a width. So width cannot be negative. You can't have a negative width. Measurement can never be negative. So the only thing that we have for an answer is w is equal to 4. So now I can say that my width is equal to 4 feet, and then I can also figure out my length. Remember that your length was equal to 4w minus 2. So that value of w that we found was w is equal to 4. So now I have that my length is going to be 4 times 4, which is 16, minus 2, which is 14. So I have my width of 4 feet and my length of 14 feet for this bulletin board. And here, I guess, you really need to know that the bulletin board has the shape of a rectangle, okay? And that's how I was able to do this problem. So let's go to example number 3. So here it says that Gianna is going to throw a ball from the top floor of her middle school. When she throws the ball from 48 feet above the ground, the function h of t models the height h of the ball above the ground as a function t. Find the times the ball would be 48 feet above the ground. So I know that they gave me this equation. So there's my equation. So h of t is equal to a negative 16 t squared plus 32t plus 48. So what does it say? It says that h represents the height. So this is the height that they're talking about. They also know that you're going to have time, t. And don't forget your h is equal to your height and t is equal to your time. So we want to know, find the times the ball will be 48 feet above the ground. So what they give you is this 48 feet. So we know that feet represents a height. So this is what our h is going to equal. It's going to equal to a 48. So I have 48 is equal to a negative 16 t squared plus 32t plus 48. So now to solve for this, I'm going to have to get this equal to 0 because of the zero product principle. So minus 48 to both sides. So now I have that 0 is equal to a negative 16 t squared plus 32t. So then from here, I want to factor. And I definitely have a greatest common factor. That's going to be my negative 16t. So I'm going to have a t, and 32 divided by a negative 16 would give me a negative 2. So now I have negative 16t is equal to 0. And I have that t minus 2 is equal to 0. So here, 0 divided by anything would just be 0. And to get the t by itself, I add it to 2 to both sides. So I get t is equal to 2. So when t is equal to 0, remember this is time is 0. So if this is going to be seconds, this is going to be, your initial time. So then t is equal to 2, that's going to be your time is equal to 2, so it's going to equal to your 2 seconds. So the height of 48 feet will be reached at t is equal to 0 and t is equal to 2, which is 0 seconds and 2 seconds. Okay, and I don't know, this also could have been said the initial value. So number 4, our very last problem. It says the product of two consecutive odd integers is 63. Find the integers. So remember, consecutive odd integers. Let's think about the number line. So we have 0, -1, 1, 2, 3, 4, and it keeps going on to positive infinity. And we keep going on to get, our negative infinity. But let's just say we are starting with some odd integer. Let's just say it's 1. Why not, right? Well, the next consecutive odd integer, if we're at 1, would be 3. So if I start at this value of x, I had to add 2 to get to my 3. So I have x and I have x plus 2, since I had to go over 2 places. So your first odd is represented by x. Your second consecutive odd is represented as x plus 2. So when it specifically says that I have the product, well, product means to multiply. So you have the first thing being multiplied by the second thing, and it says that it is 63, so it equals to 63. So the two things that are being multiplied are the two consecutive odd integers. So that would be your x and your x plus 2. So when I FOIL, since you cannot set this, and split it, because I need this to be the zero product principle, so I need this to be 0 first. And in order to do that, I need to FOIL and then add, or then subtract my 63. So when I FOIL, I get my, or better yet, not FOIL, but distribute. Since you're multiplying x times x and x times 2. So your 2x is equal to 63. Now I can subtract 63 from both sides. So that x squared plus 2x minus 63 is equal to 0. Now if I were to factor this, then there is not any greatest common factor, but I am going to do my guess and check. Since the first is x times x, and 63 I know can be divided by 9, and that's 7. Oops. And that would be 7 and 9. To get a positive 2 would be a positive 9 and a minus 7. So I have x minus 7 is equal to 0. And x plus 9 is equal to 0. So x is equal to 7, and x is equal to a negative 9. So now you know for your first odd, which is x, you got 7. And for your second odd number, remember that's your x plus 2, so 7 plus 2 gave you 9. And And don't forget, you also have your first odd as this x is equal to a -9. So then my second odd would be x plus 2. So -9 plus 2 would give you a -7. So it could be +7, +9, or it could be -9 and -7. And that makes sense, right? -9 times -7 is a +63. So you have the negative and the positive of these numbers. Okay, and that is the end of chapter 4. If you guys have any questions, comments, or concerns, please feel free to email me or the Math Success Center or our embedded tutor. Thank you.